Hi, class. This is Mrs. Albritton, and today I'm going to go over the Unit 1 Mid-Unit Assessment Study Guide. We're having the Unit 1 Part 1 test on Wednesday. It's on radical operations and rational and irrational numbers. Let's start with number 1. Which number is equivalent to 7 square root of 12 times 5 square root of 9? Well, first you want to answer the bullet points here, because what I want you to do is just think about what is it that you're doing on this problem. What operation is this problem requiring you to perform? Well, this is a multiplication problem. So you just need to write multiply. Once you perform the operation, what is the last step? Remember the steps of multiplying radicals. Step 1, multiply the coefficients. Step 2, multiply the radicands. And step 3, simplify. So once you perform the multiplication operations, the last step, simplify. What does it mean when it acts is equivalent to? And that means simply is equal to. And the reason why I put that on there is because some of the language on the test is something we haven't actually used a lot in class, but it'll act is equivalent to, and that means is equal to. So let's choose the correct answer for the problem. 7 radical 12 times 5 radical 9. So I'm going to work that out. And 7 radical 12, even though the first step says to multiply the radicands and then multiply the coefficients and then multiply the radicands, some students like to go ahead and simplify their radicands first. And keep in mind, you won't be able to use a calculator. So instead of getting to step 2 where you multiply 12 times 9 and get a large number that you have to simplify later, it may be to your benefit to go ahead and simplify the square root of 12 and the square root of 9 first. What I'll do is I'll do both ways. So let's start with the steps that we already know. If I multiply the coefficients, 7 times 5, I get 35. And if I multiply the square root of 12 times the square root of 9, I get 108. And that's what I was saying. So now you got to simplify 108 without a calculator. But we can do that. We can use a factor tree. And I've always said that if you're breaking down a large number and it is an even number, you can always start with 2 as one of your factors. And in this case, 2 times 54 will give me 108. And I can use 2 again because, again, 54 is an even number. That 2 times 27. And when I get to 27, I realize that that's a pretty common number. And that would be 3 times 9. Lastly, I would have 9 broken up, and that would give me, let me move this up a little bit so I'll have some room here. That will give me 3 times 3. So what we have here is we still have our 35 as our coefficient, but I can rewrite 108 as the product of these prime factors from the factor tree. So I have 2 times 2 times 3 times 3 times 3. And at this point, I need to pair up any matching factors. So I've got a pair of 2s and a pair of 3s. What that means is I've got my coefficient of 35 times, I pull out one of the 2s from the pair, I pull out one of the 3s from the pair, and this other 3 is left remaining inside the radical. And then when I multiply 35 times 2 times 3, I end up with 210 times the square root of 3. And that gives me an answer of D. So that's number 1. And that's doing number 1 using the steps that we're familiar with. Step 1, multiply the coefficients. Step 2, multiply the radicands. And step 3, simplify. Now, I will give the other method that I was talking about where some students will simplify the radicands beforehand and then start multiplying so that they can get smaller numbers to deal with later. I'll show you that on the next video.